In this video, I'm going to use substitution to evaluate a definite integral with trigonometric functions. It says use substitution to evaluate the definite integral given below. And they say 4 sine to the fourth x cosine x dx. I think it's pretty clear because of this to the fourth power piece that we're going to say u is equal to sine x. Because if I take the derivative of sine x, I get cosine x, so I'd be able to cancel that. Now, to find my new upper and lower bound, so I'm going to say upper bound, I'm going to do u equals sine of pi over 2, which would be u equals 1, because sine of pi over 2 is 1. And then I'm going to do the lower bound, would be u equals sine of 0. Sine of 0 is 0, so I get u equals 0. So I'm going to rewrite this as equal to the integral from 0 to 1, 4 of 4 u to the fourth cosine x dx. And then I'm going to do the derivative of u. So go back to this piece, do the derivative on each side. So the derivative of sine x. And I end up with du over dx equals cosine x. Multiply by dx, I get du equals cosine x dx. Divide by cosine x, I get du over cosine x is equal to dx. Let's resubstitute this in over here. So I get the integral from 0 to 1 of 4 u to the fourth cosine x all over 1 times du over cosine x. You can see that the cosine x's would cancel, and I'm left with the integral from 0 to 1, 4 u to the fourth du. When I do the antiderivative there, I get 4 u to the fifth over 5, and I'll be evaluating that from 0 to 1. So I end up with 4/5 1 to the fifth minus 4/5 of 0 to the fifth. So I end up with, that's 1 times 4/5, so I end up with 4/5 minus 0. So 4/5 is my area for the given integral.